Hello everyone, welcome to the night class. Today's lesson we're going to be talking about, it's lesson 4.4 in your books, and it's basically inequalities with two variables. So we're going to do some graphing and answer some other questions as well as writing our own inequalities. So let's get started. We got a few examples to get going. Our first one is just basic. They want us to, it says, what is the solution of the inequality? Y is less than or equal to x minus 1. Well, there is a lot of solutions to this problem. So the only way you can write the solutions is to demonstrate it with a graph. X and Y points are going to be all over this that work, and we have to figure out where is the region of the graph where the points satisfy the inequality. So the way we do that is we graph. And we graph just like you graph a regular line. So just like if this were y equals mx plus b, you graph it just the same way with a little difference because it is an inequality. So the inequality means we're going to have to do some shading, and we may have to draw a dashed line instead of a whole line. So we'll cross that bridge when we get to it. So first we're going to start off. We are going to graph the y-intercept, which is -1, right there. So -1, make a dot at -1, and then our slope is 1. It's an understood 1 in front of the x right there. So we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and you just keep going like that. And the more points you draw, the straighter your line will be. You can also go down 1, left 1, down 1, left 1, down 1, left 1. And since it's a less than or equal to inequality, I'm going to draw an entire straight line through all those points, and it goes forever. And here's the inequality part. So it's less than. So that means I want to shade. Greater than means you shade above the line. Less than means you shade below the line. So every point that's below this line is a solution to that inequality. So just for example, this would be a point that's a solution to the graph. Let me see if I can't find a different color, maybe show up a little bit. That's a little better. That's a point that's an equation that works for the graph. This point right here would be a solution to the graph. This point here is a solution to the graph. Any point that's on that line or below it. All these points that are on the line are also solutions because it said less than or equal to. So that's the basic way of doing it. Let's try another one. This one this time says greater than x minus 1. So I'm going to do the same thing. I start out with my y-intercept. It's -1. My slope is still an understood 1 there, so we go up 1 over 1, up 1 over 1, as many times as your graph allows, or down 1, left 1. You only actually need 2 points to draw the line, but like I said earlier, it sure does help to draw a straight one if you have a bunch of points. So this time it is not equal to, it's just greater than. So since there's no equal to sign with it, you draw a dashed line rather than a solid line. And then this time, since it's greater than means we shade above the line. Now, besides being dashed and shading above, this one's also different because all the points on the line for this problem would not be solutions because it is a dashed line. So none of the points on the actual line here would work, but all of the points above in this reddish part, all of these points are solutions. So as long as it's in the shaded part, it is a solution. Another example, example 2. We get to rewrite an inequality to graph it. So this one, we have a goal here. It says the Science Club sells t-shirts and chains to raise money. How many t-shirts and keychains must they sell to meet or exceed their goal? So first off, t-shirts and keychains. So I'm going to let, it doesn't matter, I'm going to let the t-shirts be my X and the keychains be my Y. And you can see the goal up here at the top is at least $500. So we have to write an inequality that shows how much money we're going to make. So we already said the t-shirts are $10 each. So we're going to make $10 for every t-shirt we sell. Plus the keychains are $2 each. So plus $2 for every keychain we sell. And our goal is at least $500. So we could exceed, it says to meet or exceed their goal. So that means we can have greater than or equal to $500. So we at least want 500, but it can be more. And then we graph this. Now, you can solve this equation for y. I don't really like doing that on this particular one because I can do it a different way. And here's a different way. I'm going to make a table real quick. And since this is a real life problem, if you notice, I only drew quadrant 1 here of my coordinate plane. Okay, this would be my x, these are my y. So I can figure out what the graph is going to be. It's only going to be in quadrant 1 because I can't sell negative t-shirts and I can't sell negative keychains. And so I only need the first quadrant. So I am going to find the y-intercept by plugging x in, 0 in for x. And when I plug 0 in for x, I'm going to just cancel this out because that goes away. And I'm left with 2y is greater than or equal to 500. And if you divided both of those by 2, you would realize that 250 is your y-intercept. And then basically I do the same thing for the other one. So I find the other intercept. So we just found the y-intercept. Now we're going to find the x-intercept. Well, to find the y-intercept, x is 0. To find the x-intercept, you let y be 0. And so what I'm going to do, I want to see if I can erase this. And since y is 0, that means that's going to cancel out, just like that. And I'm left with 10x is greater than or equal to 500. You would divide both sides by 10, and so x will be 50. And now you have your x-intercept and your y-intercept, and remember earlier, you only need 2 points to graph a line. So those are my 2 points. So I am going to just draw my scale here. Now, I am not going to let my scale be the same on both because 250 is a long way to go. So I'm going to count by 50s on the y-axis. And I'm going to count by 10s on the x-axis. And remember, you can count by whatever you want, whatever makes the graph make sense. And so we have a y-intercept at 0 to 50 and an x-intercept at 50, 0. And we will just connect those 2 dots. Again, we don't have to go past them because if we go past them, we'll be in negatives, and there's no negatives for this particular problem. It's greater than, so we're going to shade everything above the line. So everything above the line would be a combination that works, that would work to exceed our goal or get $500 exactly. So another example of this, they're using their graph. Okay, their graph's a little better than mine, but they have graph paper, and that's always a plus. So it says, will the science club meet their goal if they sell 30 t-shirts and 90 keychains? So I'm going to try to use the graph we just made to see if this works. So if I go to 30, which would be right there, and up to 90, 90 is right above the 80. Okay, so this would be 120 here. So I am not confident enough to say that works. So if you're not sure, remember, it has to be on that line or above it. If you're not sure, you can always plug it into your original inequality. And let's just see if this works. So this is supposed to be 30 and 90. So let's plug in those numbers. 10 times 30 plus 2 times 90. And let's see if that's greater than or equal to 500. If you add those up, that will be 300 plus 180, and that's 480 is not greater than or equal to 500. So this would be no, this is not a solution. Had they given me a different point, let's say they had given me 41, 120. Well, then that would have been a little easier because I know 40, 120 right there, that is definitely in the shaded part, and I wouldn't have even had to have done all this extra work. I could have just looked at the graph and known, hey, 40, 120 would work. If I sold 40 t-shirts and 120 keychains, I would definitely make at least $500. It would be more than that because it's in the shaded part, not on the line. So every point on that line there, you're making $500 exactly. Anything above that line, you're making more than $500. Example 3. Here we are basically going the other direction. It's giving us the graph, and we have to write the inequality. So this is not really hard at all. We know we're going to be y. Okay, it's shaded above. The graph is shaded above, so I know it's going to be greater than. And since it's greater than, and notice the line is a solid line, so that means it's equal to. And other than that, now it's just figuring out what is my y-intercept and what is my slope. So we'll start with the slope. So the slope, if I went from this point to that point, I would rise 1 and run 1. And 1 over 1 is 1. Okay? And it's a positive 1 because it's going up from left to right. My y-intercept is just where it crosses the y-axis, which would be -3. And then, like I said earlier, you just plug it in. But rather than putting an equal sign, you put the appropriate inequality. So this would be 1x minus 3. So these are nice and quick and easy. Another couple examples here. Just doing it kind of quick here. We got y. It's shaded below. So that's going to be less than, and it's not equal to because it's a dotted line. My slope, if I went and I counted my slope, we're going up 1 over 3. So 1 over 3, and since it's going up from left to right, it would be positive 1 over 3x, and my y-intercept is 0. So I don't even have to put plus or minus anything. It's just y is less than 1/3 x. For part B, we're going to have y. This time we're shaded again. We're shaded below, so it's less than, but we have a solid line, which makes it equal to. And my slope here, let's see here, if we went from there to there, we go down 1, 2, right 1, so that's 2 over 1. And since we're going down from left to right, that means it is negative. So -2 is my slope. My y-intercept is 1. And then you just plug in. So -2x plus 1. Finally, example 4. We're graphing again. They just give us, it's one variable in the coordinate plane. So we're used to graphing these like on a number line. So just so you remember, you'd have 2, 3, 4, and you remember this was the kind where you'd put, okay, this is a closed dot because it's equal to, and you shade in the direction of the arrow, so you would shade to the right. Hopefully you remember doing those, okay? So basically you do the same thing here, but it's in a coordinate plane. So you have x, you got y, you just have to graph it. Now, x equals 3 is a vertical line at 3. So just like that. Now, our equation is x is greater than or equal to 3. So we're going to draw that vertical line because it's equal to. It's not a dashed line, it's a solid line. And we basically shade the same way you did back over here on the number line. We shaded to the right because the arrow told me that it was pointed to the right. So that's the same thing you do on a coordinate plane. You shade to the whatever side the arrow is pointing to. Okay? And so that is, got a little, wow, I didn't mean to do that. Just know I got a little too far on my shade there. Well, let's see if I can put it back. Will it let me? There it is. Got a little too far on my shade right there, so sorry about that. You can also do just y. So a y is less than 2. So again, I go up on the y-axis to 2. This time it is a dotted line because it's just less than, so I draw a horizontal line for for the y's. Y's are horizontal, x's are vertical, okay? And we can go up or down here. So it's less than, so we will shade everything below that line. Okay? Hope this lesson helps you. Good luck on whatever problems you're working, and we'll see you next time. Stay above the line.